Hi, Sanjhali. How are you?
Hello, sir. I'm good.
Am I audible?
Yes, sir. Am I audible?
Yeah, बिल्कुल. Okay. So, yeah. So, you are sharing your screen or on board?
Sharing my screen.
Yeah, then share your screen first.
Yes.
Very good. Yeah. Okay. So, yeah, tell us about yourself, your academic background, what you like the most in mathematics, in statistics. Okay.
Yes, sir. So, my name is Sanjhali Parmar, and I'm from Kashipur, Uttarakhand. And I've done my graduation from Ramdas College, University of Delhi. And in mathematics, I would prefer linear algebra. I mean, I have studied everything, so yeah.
Graduation in which subject?
Statistics, PSC honors statistics.
Okay. Okay. So you okay? Shall I start asking question or of course I
Yes,
can
sir.
start. Of course. Okay. Yeah. So my first question is, you know what linear transformations is?
No, sir, I'm not very familiar with that.
You have to study linear transform. Okay.
I studied, sir.
Okay. Okay. Let me ask another question. What is orthogonal matrix?
So a matrix A is called orthogonal if we can write A into A transpose is equals to identity matrix, where A is a square matrix.
Okay. 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 Construct a 2 cross 2 matrix with a complex eigenvalues. Yeah, it's a very
So
simple question. Construct.
uh, it should be orthogonal or any matrix.
Are you writing on your screen? Uh, It is not
No, sir,
visible.
not yet. I have
Then
not
write.
written anything. So, so the question is I have to construct a 2 cross 2 complex matrix.
No.
Just
You have to construct a 2 cross 2 real matrix having complex eigenvalues.
okay, so 2 cross 2 here.
Okay.
Where is this?
What are the eigenvalues?
So I'd have to calculate that using the characteristic
Be
polynomial.
louder. Sanjali, be louder.
Okay, sir. So I would have to calculate that using the characteristic polynomial lambda minus AI determinant, which will be equal to lambda and this one, sorry, I've done something wrong. Minus lambda I determinant. It would be minus lambda, and then 1 minus 1. Lambda square plus 1 equal to 0. So lambda would be plus minus iota.
Very good. So the eigenvalues are iota and minus iota,
Minus
right?
iota. Yes, sir.
Okay. Very good. Okay, so the next question is so obviously this statement, like if at least one eigenvalue is zero, then determinant must be zero.
Yes, sir.
Can you prove this a little bit? I mean, the reasoning behind this.
Okay. So I'm taking a 2 cross 2 matrix for that. And I take number 1 as 0 and another number 2, 3 would be 1, 2, 1, 2.
What is
So,
this? 1 2 1 2.
that, so I'm taking an example.
So you are proving the statement by taking an example.
Yes, sir.
No, this is not the correct way.
So we can use that formula that determinant of an matrix is the product of its eigenvalues.
Yeah, you can use.
So
And one
if
more thing, you can use that you wrote in the previous question, that determinant of a minus lambda equals to zero.
hmm,
If lambda equals to zero, then determinant will be zero. See how simple it is. Okay.
yes, sir.
So don't prove any statement by taking an example. See,
Okay,
this
sir.
is the wrong way.
Okay,
Okay.
sir.
And yeah. Next question is, what diagonalizability is?
So for a matrix, if we can say a matrix is diagonalizable, n cross n matrix, if we can write it in the form of X transpose A. If there is a invertible matrix P such that P inverse A P is equals to a diagonal matrix D, so then A would be a diagonalizable matrix.
Okay. Okay. Very good. And what is the minimal polynomial for a matrix?
So I'm not very sure about it.
Okay. 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 Yeah. So I'm asking from a basic matrix theory, like if AB equals to zero, write it. If AB equals to zero, there are two matrices. Okay. A and B.
Hmm.
Yeah. AB equals to zero.
Hmm.
Does it imply that A equal to zero or B equal to zero?
No, sir, it does not imply that.
Yeah. Can you provide an example?
Yes, sir. If we take A as 0, 1, 0, 0, and B as 0, 0, 1, 0, then no, it's not.
Very good.
No, sir, that
So
will not be
AB is
equal to.
zero.
Yes, sir.
No? No.
Yes, sir, there's.
AB is not zero.
Yes, sir, that's what I'm saying. That there's some issue. Just a minute, right? Okay.
Hey, don't rub it. No. Modification
Okay,
is just take A equals to B and B equals to A. Just was the case.
okay, sorry.
Your second matrix should be A and the first matrix should be A.
Yes.
Very good. So the statement is not true. Like if AB equals to zero, then BA cannot be zero, right?
Yes, sir.
Okay. What about if AB equals to I? Is it possible that BA cannot equal to I? Means identity matrix?
No, sir, that is also not true.
You
Because,
got my question, or
yes, sir, you are saying that if AB equals to I, then
does it imply PA equals to I?
BA equals to I.
Equals to I.
Okay. Sir, I think it is true.
Is
True, I think
why?
so. So because if AB equals to I, then we can say that A is equals to B inverse if B is an invertible matrix. So if
Very
A
good.
is equals to B inverse, then A would be equals to B inverse. That would be equals to I.
Very good. Very good. Very good. Very good, Sanjay. Okay. And what was my first question? Can you recall?
So if uh, A A is an orthogonal matrix, no. A real matrix with complex eigenvalues.
Okay, just reverse the question. Like, can a matrix with complex entries having real eigenvalues?
Let's see. It could be possible. I think so.
Consider them.
So I am constructing a 2 cross 2 matrix for that.
What?
I am constructing a 2 cross 2 matrix for that.
Yeah, sure. You have freedom to choose your own order. Good.
Yes, sir.
Very good. Very good. What are the eigenvalues?
I think that would be plus minus 1, maybe.
Plus minus one.
1. Yes.
Very good. Okay. Can two matrices have the same eigenvalues, but the matrices are different?
Yes, sir. I
Consider.
just want. Wait. So these two will have same eigenvalues, but they are different.
Very good. Very good. So you know what is a subspace, right?
Yes, sir.
Okay, write a set, then check this is subspace or not. Okay.
Yes, sir.
So the set is S equals to bracket ordered pair x comma y, not this one, the middle one. Good. Ordered pair x comma y, very good, belongs to R square such that x plus y equal to 0.
So for subspace, we can check three properties. If they exist, then we can say that S is a subspace. So first one would be if 0, comma 0 belongs to S, and we can see that this property is fine with this set. Second property is if alpha x comma alpha y belongs to S, where alpha is any number belonging to real number line, and we can show that if x plus y is equals to 0, then if we multiply alpha to both sides, then we can say that alpha x plus alpha y is also equals to 0. So that means this property is also fine. Third one is um, x1 plus x2 comma y1 plus y2 should belong to S, where x1 comma y1 and x2 comma y2 belongs to S. So if x1 plus y1 equals to 0 and x2 plus y2 equals to 0, then adding these two equations, we can say that x1 plus x2 and y1 plus y2 is also equals to 0. So that means this property is also fine. So it is a subspace.
Very good. Very good. And what should be the dimension of this subspace?
So dimension should be 1.
Very good. What is dimension, by the way?
So dimension is the number of elements in the basis of this subspace.
Aortic basis.
So basis is a set which is linearly independent, and span of that set can produce S.
That space. Very good. Very good. Okay. Now, can you construct an example, Sanjhali, so that the vector space is of infinite dimensional and finite dimension also? See, you have to construct two example,
Hmm.
both finite dimensional and infinite dimensional.
So for finite dimension, we can construct V as uh, a polynomial of degree 2.
Don't you think just take the above one?
Yes, so we can take that also.
Okay,
This
it's
is a
fine. Yeah.
and polynomial of 2 degree. And for infinite one,
And what about infinite dimensional?
yes, I'm thinking about it. Just a minute. Sir, I'm not like getting
Okay,
any.
okay, okay, it's fine, it's fine, it's fine. Okay. Raghav, how much time I am having?
Sorry, sir, what?
How much time I am having now? I mean, it's already 12:40.
Well, you can take as much time as you want. I mean, lunch
Okay,
after this.
so
So,
one or two last questions, Sanjali. Okay.
Yes, sir.
So, okay, you want to choose any particular topic that you are enough confident or ask from this topic?
So real analysis or differentiation integration,
Oh,
anything.
you are interested in real analysis also.
Yes, sir.
Okay, but don't do that. Okay, I will give you feedback in the last, but choose only one topic in mathematics. Otherwise, it's very difficult.
Okay, sir.
Okay. So I'm particularly asking from linear algebra.
Okay.
Okay, what about skew-symmetric matrix eigenvalues?
So skew-symmetric matrix, it has uh, all complex eigenvalues, and if it is of odd order, then it can have it will have a zero eigenvalue plus complex eigenvalues.
Complex means what? The real eigenvalues also the complex eigenvalues. So you are saying in general, like if I'm asking for a general matrix, then the your answer is also true for that question. Then okay.
Okay, then
So rather than using complex, use purely imaginary.
okay, sir.
Okay.
Yes, sir.
What about the determinant of this matrix? Skew-symmetric matrix. Real skew-symmetric matrix.
Okay, so determinant would be like it could be non-zero if it has complex eigenvalues. All of its eigenvalues are complex. That would happen in the case if its order is even. But if it's of odd order,
Order is
then
order is
even.
you told zero.
No, sir.
Okay, it's
In
fine then.
not
Okay.
order.
What is characteristic polynomial?
So characteristic polynomial for a matrix when we write A minus lambda I determinant. So the polynomial that would be generated solving this equation, that is characteristic polynomial.
Then write it equal to zero.
Okay.
That is the equation. No? You
Yes,
wrote
sir.
only determinant part. Okay. Yeah,
Yes, sir.
that will be the characteristic polynomial. Okay.
Yes, sir.
And if you are saying equal to zero, then it will be
That's it.
characteristic equation. Okay.
Yes, sir. Yes, sir.
Okay. Okay. And what I was asking. Okay. You know what is the index of a nilpotent matrix?
Yes, sir. So
Then write the definition.
a nilpotent matrix is a matrix such that A to the power n is equals to 0, where n is a natural number and index is the smallest value of this n.
Okay. Very good. So how can you write mathematically?
We can write the index of,
No, no, just if a to the power n equals to 0,
okay,
n belongs to
okay,
1, then a to the power
then
n minus 1
would
should
not
not
be
be
equal
0.
to 0. Okay.
Very good. Okay. The last question is uh, index should be less than equal to order of that matrix. Is it true or false, first of all?
Less than equal to.
Are you getting my question? The
Yes, sir.
question
Yes, sir. I'm
is
thinking.
the question is a to the power index equal to
Hmm.
0. So the index is always less than equals to order of that matrix.
Okay, sir.
Is it true or false? Or index can be greater than order.
I think so. It is true.
Why?
So because we can construct an example for it, because for the equal to part we can take a diagonal matrix or a lower diagonal or upper diagonal matrix.
Again, you are doing mistake. I told you, whenever we have to prove something, don't use examples.
Okay, sir.
Do you want any hint?
Yes, sir. That's it.
What are the eigenvalues of nilpotent matrix?
0.
What will be the characteristic polynomial then?
Determinant of A is equals to 0.
Come on. Polynomial in X will be what?
Polynomial x to the power n equals to 0.
Now use Kelly-Hamilton theorem.
A to the power n is equals to 0.
Means, can you conclude now?
So n,
N is order here, right?
yes, sir.
Now can you conclude?
So, sir, it should be more than or equal to.
Again, come again.
It should be more than or equal to the order of A.
Come on. No. If it is nilpotent, then it will always satisfy a to the power n equal to 0. Then where is the smallest? Smallest means, see, you are very close, but you are not following. Okay, Sanjhali, think about it. Okay. Yeah,
Yes, sir.
Raghav, I'm done with my questions. And Sanjhali, you can text me for your feedback. I'm actually leaving for my medicines. Okay, I have to go
Okay.
hospital. Okay,
Okay, sir.
so
Yes.
you can text me for your feedback, Raghav. I'm leaving. Okay.
Okay, sir. Yeah, thank
Yeah.
you.
Yeah. Thank you, guys.
Hi, Sanjhali, am I audible?
Yes, yes. You're
Okay. I'll be asking probability questions today,
okay.
and we'll start with some basic questions. Say you have two events, A and B, right?
Okay.
And I say they are independent. So
Okay.
can you show that A and B complement will be independent?
And you is independent. This should be complement.
A and B complement,
A and B complement, not A
right?
complement.
Not A complement, right? Do you think they will be independent?
Yes, they would be independent.
Okay, so can you prove this?
This to the probability of so they are independent.
Correct. This is correct. Okay, so let's move to the next question. Say you have a non-negative random variable, continuous random variable, non-negative,
Okay.
and the distribution function is f.
Distribution function is
F. So
F.
this is not non-negative. This is positive. What you have written x greater than so yeah, right. Non-negative random variable distribution function is f. So can you write the expectation in terms of f?
Expectation of f in terms of x.
Expectation of x.
Okay.
Expectation of x in terms of f.
This
Where is x in the expression? You have written dx, but there is no x in the
f of the CDF would be
CDF should be fx.
in,
Okay.
in terms
Can
of
you
f.
prove this?
That the CDF is in terms of x.
Right. The expression. Can you derive this expression?
We can write PDF of x as equals to this. I know that this is not working, so I'm thinking of another way.
Sorry, you're not audible.
I know that this is not working, so I'm thinking of any other way.
Okay. No, take your time. What are you thinking? How are you planning to proceed?
I am trying to incorporate this part, but I don't know how to do that.
Okay. Okay. So, say I'll give you a hint. Uh, so expectation of x is integration x fx dx, right? The way you have written.
Yes,
So you
yes.
need to go from small f to capital F. है ना?
Hmm.
You need to integrate. So integration small f is capital F, right?
Oh,
So how about you do integration by parts? That's an integration term, right? When you do
okay,
integration
okay.
by parts, right?
Yes, yes. Got it.
There are many ways to solve this. There are this is the this is actually the
Yes.
longer one. There's a simpler one as well.
Can we write x f of x as equals 0 to infinity f x dx? Can we write it like this?
X fx was 0 to infinity fx dx.
I don't think so.
So why do you think that is true?
Oh, it's not true.
So yeah, what you have done, you have taken x, you have done integration of x. Why haven't you put any limit on x of x? No, x of x will
It's
also
not
have
true.
limit 0 to infinity, right?
Yeah.
Do you remember integration by parts?
Yes.
Okay.
Sorry. Is it fine now?
Not entirely, but all that this will do for now. So the x1 minus 0 part is not correct, of
This.
course, because x takes the limit also. You have taken x out of the equation. No worries, think about it later. Uh, and think about another approach also. No, think about it before like searching it on web. Think about it. There's a smaller approach as well where you use like the change of integrals. So you have a 0 to infinity x f x dx, right? So
Hmm.
you write x as another integral. You write x as say 0 to x1 dx, right? Something like that. Then you change the integral and you somehow get
Okay.
that form. Think about it once.
Okay.
I'll ask another question. Acha, say you have a random variable that follows chi-square distribution, chi-square k. Can you can you write the PDF?
This would be same as gamma k by 2 comma 1 by 2. So PDF of x would be 2. Is this fine?
Okay, this is fine. This is fine. Can you derive the rth moment of this? Can you find a closed form expression for the rth moment of a chi-square k distribution?
Expectation of x to
Right.
equal. So we'll use gamma integral here.
Okay. Yeah, correct. Fine. Fine, I'll give you another question. Huh? Say I have a sample x1, x2, xn from exponential distribution. Say exponential theta. Right.
Mean is theta or mean is 1 by
Uh,
theta?
say scale theta. So mean 1 over theta. Right. So do you know this is n data points. I from 1 to n, right? So do you know what's the distribution for the minimum order statistic?
So x1 would follow exponential and theta.
Exponential of theta. Right. And what about the maximum order statistic?
We would have to derive that.
Is so there's okay. So okay, let's leave it. There's no closed form expression for that. Uh, let's not do that. Say I just take two of them, not the whole sample. I have x1 and x2 from exponential theta, है ना? And I define a random variable y. So y is x1 over x1 plus x2. No, not the order one, just x1,
Okay.
not order statistic. X1 divided by x1 plus x2.
Hmm.
Can you obtain the distribution of y?
So do I derive it like?
Correct.
Okay.
If you do not wish to do the whole derivation, you can use some transformation or technique, some known results if you know some.
We can say that x1 would follow. Can we use that gamma over gamma?
Right? Please do that.
Okay. Okay. So we can say that x1 follows. This would follow beta 1, where 1 comma 1.
You know, beta 1, 1, is it something else also?
Uniform 0 comma 1.
Uniform 0, 1 as well. Say, now I say that theta was half. So this is independent of theta, right? Theta had no role to play here. Right. I say theta equals to half. Right. Now, if theta were half, so I could have written x1 and x2 Can you say what x1 would be in terms of chi-square?
Can you repeat that?
Say theta equals to half, then x1 in terms of chi-square.
Okay. X1 for exponential half. This is same as pi square 2.
Chi-square 2, right? So now x1 over x1 plus x2 is like a chi-square 2 over chi-square 4, right?
Yes.
So do you know what is the ratio of chi-squares?
F distribution.
F distribution. So this would be what? F24.
No, that would not be F2 comma 4.
Okay, why?
Pi square 2 over chi square 4. Because we would have to divide by the degree of freedom as well. Then it
Okay,
would
so
follow.
what would it be? Say you divide. Okay, so you're suggesting chi-square 2 over chi-square 4. This in the given scenario, this would be half of F24, right?
Oh,
So
yeah.
if it is half of F24, then is half of F24 same as uniform 0, 1? I mean, we have already said that this is uniform 0, 1.
Mhm.
So either that is wrong or this is wrong. You agree now that half of
Yes,
F24 is
yes.
not uniform 0, 1. Half because I'm like taking the left hand side for
Yes.
2 and 0. Okay.
Mhm.
So there might be some issue here.
In this one or this one?
You tell me,
Okay.
are you confident in your derivation upper wala? The gamma ka ratios being beta 1, 1 and uniform 0, 1. Are you confident there?
Yes.
Okay. Then maybe something's wrong with the second expression.
But they're both true.
They're not audible.
Something's wrong here because both of these should be independent.
That's correct. So they're not independent. That's why
Yes.
it's not
It,
F24.
yes.
That's correct. So if it were say x1 over x2, that would be
2
F22.
comma 2.
F2
Yeah.
comma 2. 2 comma 2. Okay. That's it from my side, Sanjhali. Thank you.
Thank you.
Dishari, please continue.
Yeah. Sanjhali, can you hear me?
Yes.
I'll start with something simple. Let's say you have x1 and x2 from Poisson lambda. And you have a test statistic, capital T equals x1 plus 2x2.
Hmm.
Okay. Is this a sufficient estimator for lambda?
No, this would not be sufficient.
Okay. Could you prove it?
Yes, we know. Can we say directly that summation xi is sufficient?
Yeah,
Or
that is okay, but why isn't x1 plus 2x2 sufficient?
because a 1-1 function of this t1 would be sufficient and this is not 1-1.
Okay, but could you go by the definition of sufficiency? that if x curl given capital T is independent of the parameter, then it is capital T is sufficient. Could you go by that definition?
Okay, okay. Yes, we are going.
Sanjhali, this is the correct process, but when you're going to disprove something, you could just use a counter example. Proving it
Okay,
in a more general way can be difficult. This is the right approach, but you could just take an example and show me. Let's I'll tell you. Let capital T be 2. I mean small t, the observed value of capital T be 2. So what are the values that x1 and x2 can take?
okay. So x1, 0, and 1,
Hmm?
2, 0.
Okay. Now can you find the conditional distribution of x curl? Take any of the one x curls and find the conditional distribution.
Okay,
That's okay. You don't have to calculate further. It will turn out to be, if I recall correctly, 1 by 1 plus lambda by 2, so which is dependent on lambda, and hence the capital T is not sufficient. Okay.
Yes.
So speaking of Poisson lambda, could you tell me an estimator for e power, an unbiased estimator for e power minus lambda?
Sample sizes n or
Yeah,
two.
take sample size n or 2, anything. Take sample size n.
So we can use Rao-Blackwell theorem.
I'm not asking you to find the minimum variance unbiased estimator. You could just give me any unbiased estimator.
Okay.
Yes, of
Okay.
course you can use Rao Blackwell. Any unbiased estimator will do.
Okay. So probability x1 equals to 0.
Right. So can you use the entire sample now?
Probability summation xi equals to 0 or x bar equals to 0. No. Sorry. This would work.
So when you say probability, it turns out to be in the form of lambda, right? So probability x1 equal to 0 is e power minus lambda. So you're telling me what's the unbiased estimated here?
This.
A probability, how can a probability be an unbiased estimator? It might be unknown. Probability x1 equals to 0 is
Okay.
e power minus lambda.
Okay.
You're doing well. This is the correct approach, but I think there's some technical issue to be sorted here.
Okay. I'm thinking about it.
Do you know about indicator functions?
Yes.
How about you take indicator, define some psi x.
Can I use MGF part also?
How are you going to incorporate MGF?
Because we know expectation of e to the power tx. This is equals to e to the power. Okay, so that would not be minus lambda. Okay.
So
No.
just take a function.
Lambda.
Okay.
If we take p is equals to no, that would not be.
Just do this instead. Take a function phi x, which is 1 when xi or x1 equals 0 and 0 otherwise. So could you calculate the expectation of phi x? So is phi x an unbiased estimator?
Yes.
So you could also write phi x as indicated xi equals to 0, right?
Yes, yes, yes.
So now can you tell me, this is a random sample. Could you incorporate all the n sample points, uh, keeping in mind that you can use an indicator function?
Okay.
I'll give you a hint. So let's take a normal distribution. So we know that if x1 up to xn follows normal, say theta comma 1, then expectation x1 is theta. And expectation x1 plus x2 by 2 is also theta. Expectation x bar is also theta. So if you can construct an unbiased estimator using one sample point, you can just take the mean of the entirety of the sample points and you will also have an unbiased estimator, right?
Yes.
So could you write it down?
X bar would be equals to summation xi over n.
But xi is not the unbiased estimator here. It's indicated xi equals 0.
Okay. So uh, in place of xi, we can take phi xi summation.
Yes. There will be a 1 by n. So I have one last question for you since it's almost 1:30 already. Let's say t is a sufficient statistic for any parameter theta. And you said initially that if uh, there is a 1-1 function of t, then it is sufficient, right?
Yes.
Now I'm telling you that if t is a function of some t star,
Okay.
then would t star be sufficient for theta?
Is it a 1-1 function?
It can be anything. If you need a hint, just tell me, just to get started on.
Okay. So if uh, g is a bijective function, both 1-1 and onto, then we can write that t star is equals to g inverse of t, and that would be 1-1. So then it would be sufficient.
Right. What if it's not bijective?
It's not bijective. Can we take an example?
You cannot. If you want to take a counter example and disprove this statement, you can. But if you want to prove this statement, then you have to prove in general.
Okay. Can you give an hint?
So, you know how we can find sufficient statistic using Neyman-Fisher factorization theorem?
Yes.
Could you write how we would express, let's say x1 up to xn is a random sample following some f theta x curl. And could you write how we could express f theta x curl in terms of the sufficient statistic t? Correct. Now can you incorporate the fact that T is G T star? Take this as some F or some
Yes.
phi
Yes.
or something. You already used F, but it's okay. Just take it as F star or G star. It's okay. I get it.
So this would also be sufficient then.
Right. Right. So the Niemann-Fisher factorization theorem still holds, and you don't have to check for bijectivity or anything.
Okay.
Right. Okay. Okay. That's it.
Vishali, are you done?
Yeah. Recording was good.